Hello viewers, this is Karthikeyan, Professor of Electrical Engineering. In this video, I am going to tell you one small shortcut so that you will be able to find the range of K in Routh stability criterion. You will be asked to find the value of K or range of K for the system to be stable. For that, you will be given with a characteristic equation. To understand this concept, let us assume one simple characteristic equation that is nothing but s cube plus 10s square plus 9s plus k. If you want to formulate the Routh array, you will be writing the s power in descending order. So s cube, s square, s power 1 and then s power 0. Then elements must be listed here. The first two elements are 1 and then 9. 1 and then 9. The second row elements are 10 and then k. So in this way, you will be filling the elements. Then you will be calculating the next row element by Routh procedure. 10 into 9, 90 minus 1 into k divided by 10. So this will be the element in the row corresponding to s power 1. Then next row element will be, we don't have any element below this k. We don't have any element below this k, so that this k gets repeated here. So this will be the Routh array. In this Routh array, it is given that the system is stable. If the system is stable, then all the elements in the first column must be positive. There should not be any sign changes. If all the first column elements are positive, then k value should be greater than 0. K value should be greater than 0. So this is the lower limit. In order to find the upper limit, you equate this 90 minus k divided by 10 is equal to 0. If you equate it, you will be getting k is equal to 90. So k is equal to 90 is the critical value. Critical value, it means if you substitute k is equal to 10, then your system will become marginally stable, because here the first element becomes 0. We don't have any second element, so that a complete row becomes 0. So your system will become marginally stable. K value is 90. K that is nothing but critical value. It is given that your system is stable. If your system is stable, then k value must be less than 0. So the range of k will be lying in between 0 to 90. So in this way, we usually find the value of k. So here what you can do, instead of proceeding with Routh array, you can substitute s is equal to j omega in the given characteristic equation. So that you will be getting j omega cube plus 10 j omega square plus 9 j omega plus k is equal to 0. You know that j cube is minus j and j square is minus 1. Now here you have j cube is minus j omega cube minus j square is minus 1, so minus 10 omega square plus 9 j omega plus k is equal to 0. Now you separate the imaginary parts and real parts. The imaginary terms are minus j omega cube and then 9 j omega. So equate that part to 0. Minus j omega cube plus 9 j omega is equal to 0. From that, if you calculate the omega square value, omega square is 9. Now equate the real part to 0. Real parts are minus 10 omega square plus k. So minus 10 omega square plus k is equal to 0. K is equal to 10 into omega square. We have calculated the omega square value. Substitute the omega square value here. 10 into 90, you will be getting the 90. 10 into 9, which will give you the 90. Here 90 is the critical value. 90 is the critical value. If the system to be stable, then k range must be 0 to 90. So in this way also you can find the value of k or range of k in Routh forwards criterion without applying the Routh table procedure. Thank you for watching.